The NGLV, we are planning to have a 2.2 times than the existing vehicle, and with a thrust to lift 125,000 tons of vehicle. So to take care of this thrust and other requirements, a new launch pad, which will also act as a standby for the LVM-3 when the demand increases. That's how this launch pad is being conceived, and it will have its own associated facilities for the fuel servicing for the new engines that are being developed as part of the NGL vehicle. Thank you.
Now we'll ask the satellite director to answer this question. The question is, to complete the Navy constellation, probably how many more satellites are required? What is the currently auto?
To find a solution, that is position, navigation and timing. For timing, one satellite itself is sufficient. For position, 4 satellites are sufficient. So we are having a solution, indigenous solution with respect to all the IRNSS constellation. We can have a solution. PNT is available.
Okay, before we close this press meet, let me add 2 more points. You know the Gaganyaan program, taking man to the space and bringing back, this we are working, and we are in the advanced stage of development. In fact, before taking the actual man to space, 3 uncrewed missions are planned, and the first uncrewed mission, lot of development activities are going on. And now I will ask the PMC chair, Mr. Unikrishnan Nair, just to add the current development status. Don't commit on the schedule and everything will this one. So development status, just 1 or 2 points you add.
The human-rated LVM-3 is a derivative of LVM-3. But though it is a derivative, it is a totally new vehicle. Its configuration is different, its architecture is different. It has got an integrated vehicle health monitoring system, it has got an escape system. So it's a totally new vehicle. So the vehicle, all the technologies needed for the vehicle you have realized, and in fact all the vehicle stages like S200, L100 and cryo stage, all the vehicle stages have reached, and the crew escape system, systems also have reached, and we started the assembly. So we are all gearing up for the first uncrewed mission. And in terms of technology, the important part is the human rating of vehicle, which we have successfully completed. And then developing the very reliable, high reliability crew escape system, that also we have completed. We have done 1 test vehicle flight to demonstrate its in-flight demonstration. We are going to have another 3 more test vehicle flights, and the second test vehicle flight to demonstrate in-flight crew escape system will be done within a few months from now. And there will be other tests, like we wanted to test the performance of parachute, so we will be dropping from a helicopter. That also maybe in another 1 or 2 months it will be done from Sriharikota. So in different fronts, technologies are getting developed, and we are all gearing up for the unmanned and crewed missions. From that, we will be going to man the mission. Thank you.
Thank you. So one more point is the next generation launcher, what we are talking, NGLV, is going to, as I told, 30,000 kg it is going to lift, and it is a 91-meter height rocket. Our Mark 3 is hardly half of that height only, and that is going to use a new propulsion system called LOX methane propulsion system. This major development is going to take place in LPSC and IPRC, and of course other centers will support like VSLC, SDSC, SHAR for testing will support. Now Mr. Mohan has taken over as the director of LPSC, so he will brief you only on the current status of the LOX methane engine development. Of course, Mr. Asif Pakiraj is also equally responsible. Now we'll ask Mohan to brief 1 or 2 points on the LOX methane engine development. Please.
Good morning to all. Yeah, as Chairman has pointed out, the NGLV, the next generation launch vehicle, is going to use the propulsion systems out of the LOX methane engine, and the preliminary design of the engine has been completed, and the development test also has been completed. Now the detailed engineering is happening, and we are gearing up to prepare the engine for the actual hot test and also the cycle of tests to complete the qualification. And here the industry partners are also going to play a major role, because the engine parts and the major components have to be realized through industry. And the concept of NGLV, the model going to be adopted is the design also. We are going to have the industry in the scope of R&D and design. So we hope that the engine development activity and the testing activity will commence from this year, so that we are able to gear up for the launch of NGLV. But this is a clustered locksmithing engine. So we have a lot of challenges from the thermal part, thermostructural part, and also a combined operation and also throttling. We are also looking at recovering the first stage, just like you have seen elsewhere, people are capturing the first stage, so that also is being attempted. So a lot of technological development and activities have to be realized and accomplished and qualified. So we are on the job in line with the program assigned to us. Thank you.
Maybe one or two more questions to that. Yeah. NGLV payload mass. 2,250 kg is the payload mass. Sorry, NGLV liftoff mass is 1,000 tons is the liftoff mass of the vehicle. The payload is 30 ton to low Earth orbit. In fact, we are having two versions. One is along with the strap-on, another one is without strap-on. So the maximum capability is 30 ton to low Earth orbit. The NGLV, it is going to be a 3-stage vehicle with 2 strap-ons. Strap-ons are solid. Strap-ons are solid motors, and the first stage is a locksmithing stage with 450 tons of propellant loading, powered by 9 engines. Each will generate 110 ton thrust. Second stage is again. Dear friends, very, very good morning to all of you. Today, we made a historical achievement in India, the 100th launch from the spaceport, the GSLV F-15 launcher, taking the second generation, second navigation satellite NVS-02, which is having the second indigenous atomic clock, to the required orbit and injected as expected. Now, you all know, on 16th of this month, we had made an achievement. The SpaceX 2 satellites of each 220 kg rotating with a velocity of 28,400 km per hour was perfectly docked, and India becoming one among 4th country to have the great accomplishment. Immediately after this has come, and 1979, we had the SLV-3, first SLV-3 rocket launched from this spaceport. From that, generations of leaders have contributed, developed 6 generations of launches, also a couple of important R&D activities, and today it is a historical milestone that 100th launching is successfully carried out with the effort, dedicated, sincere, single-minded, devoted, hard work and smart work of Team ISRO, along with industrial partners and academia, we have accomplished. On this day, first of all, let me also thank all of you who are waiting here to report. And this achievement is a great achievement for the country. Now, you know, we are in the process of doing lot of development activities. In fact, this month itself, we got the 3rd launch pad also got approved, and lot of new projects we have got approved, and including Chandrayaan 3, Chandrayaan 4, then of course the next generation launcher, and so many approvals have come. So our target is to accelerate entire approved projects to the greater level this year, and also lot of missions are lined up this year. So with this, we are having all our senior directors and the mission director and the project director GSLV, mission director and the project director GSLV, Mr. Thomas Tarian, and Karthik, our satellite director, all are there. So, would you like to say what is the precise orbit, what is achieved? Mission Director, can you tell that portion alone? Then we will take questions.
Yeah, as per the reporting, the accuracy in the apogee and the perigee are, it is actually 74 kilometer, something 37,500 kilometer. Out of that prediction, we could reach to it by 74 kilometer. It is not even not a simple achievement. It is a very accurate injection as far as a satellite is considered, and the apogee, perigee is 0.5 kilometer. So that kind of an accuracy one can achieve with very precise inertial navigation systems in place. So we have got wonderful navigation system development teams, and they have contributed for this particular, getting this particular achievement.
Okay, thank you. Before we go, you all know here all the senior directors are here, and a couple of senior directors are in the second row. Probably you have to cover them also, they are all there. Asif Pakiraj, of course, Scientific Secretary Victor, then Prakash Chauhan, and Human Space Flight Center Director, Mr. D.K. Singh, Mr. Bhatma Kumar, IASU Director, and STPO Director, Mr. Anrup, all the people are there. So, okay, now we are ready to answer whatever clarification you want. One by one.
Can you throw some light on take mic.
Sir, first of all, congratulations. Sir, my question is on NASA ISRO synthetic aperture radar mission by GSLV F-16. Can you just throw some light on it? How's the plan going on?
So it is one of the joint collaborative mission, and we are already satellite is ready, and we are going to launch maybe within couple of months. The details of the satellite I will ask the URSC, the URO Satellite Center Director, Mr. Shankaran, to just brief you.
So as already the name itself tells, it is a spacecraft which carries a synthetic aperture radar, and it is a collaboration between ISRO and NASA. There are two radars in this spacecraft, one L-band radar and one S-band radar. The S-band radar is developed by our Space Application Center. Nilesh Desai is here. His center is developed. The L-band SAR has been developed by the Jet Propulsion Laboratory of NASA. The whole system has been integrated and tested at URO Satellite Center. Now the spacecraft is ready for movement to SAR. Shortly we are going to flag off the spacecraft from URSC to SDSC SAR.
Sir, congratulations, sir. It has taken 46 years to launch to 100 rockets, but can the next 100 rockets to be launched in the next 5 years is possible, sir?
No, you are asking a right question. That is the target what we are aiming at. It is possible.
Pramod, this side.
Sir, congratulations on the 100th launch.
We were also waiting to get some data about the SpaceX because it was delayed a little bit, but what is the kind of technology you used in docking and
Little closer mic.
Can you hear me now?
Yes.
Congratulations, sir, on the 100. We would like to also get some data about the SpaceX in particular, because we did cover that, but we could not get exact information about the docking and unlocking, what exactly happened during that period.
Okay, say there were two satellites which was injected on 30th of last year, December last year, by the PSLV, and with a velocity, the satellites were rotating with a velocity approximately 28,400 km per hour. Two satellites are independently rotating. And these two, we have, in a step, very precise manner, step by step, we have studied and gradually, and when it was injected, it was having a distance of almost 11 kilometers. Now, to dock two things, we have to reduce the gap between them. Also, in all the three axes, the orientation, everything has to be precisely controlled. For that, there are set of sensors, there is logic, algorithms, so many things are there, and we went very carefully, meticulously. At the time, we didn't attempt to dock. and slowly moving from that place to 1 kilometer, then sub-kilometer level. Like that we are gradually moving, understanding how the sensors are working, how the algorithms are working. Finally, we have done the docking. Now, what for this docking? So, docking is meant for lot of things. For example, take our Chandrayaan 4, it is approved program. And Chandrayaan 3, the satellite mass, Chandrayaan 3, which is soft landed near the south pole of moon, the satellite mass was 4,000 kg. Chandrayaan 4, the satellite mass is 9,000 plus kg. And we cannot lift off the entire satellite through a single rocket. So we have proposed to take through 5 modules in 2 launchers. And it will be taken separately, and there in the space it will be docked, and all the experiments has to be carried out. Same way, the Honorable Prime Minister has given the approval for the space station build-up. And it is going to be 5 modules. So we are going to take individual modules to our launches, and there we are going to dock. And future, when you talk about future human spaceflight program, including manned crewed program for moon, we cannot build huge rockets. For example, to accomplish a manned crewed program, almost the 100 to 125 ton lift-off mass is required. Not lift-off mass of the rocket, the satellite mass is something around 125 tons. To have that, you need huge rocket. But then, what are we going to do with the rocket other than this application? Our plan is to take small modules and then accomplish this. So thereby, this will be further really useful. And it is a very, very great, significant achievement. If it is so simple, why only 4 countries have done this accomplishment? So is it okay, or you want anything, any other things? Okay, thank you.
The Asianet in the middle, right side.
How many satellites are currently operational within the dynamic system, and when can we expect the next satellite ending 0.05?
Right now, 4 satellites are in operation. This is the 5th satellite which is going to join in this year or 2. So 3 more satellites are already approved is there. We are planning to accomplish once in 5 to 6 months the satellite launch. And of course, 1 more satellite may be required, that we are in the process of getting approval.
Okay, in the middle, last row, gentlemen. On mic on, switch on mic.